Hello, welcome to Chapter 19. This is our final lecture of the semester, except for the final review. So this is on Chapter 19 is quantity and final surveys. Uh, this is somewhat interesting because it's a very important chapter for construction management people. This particular chapter is where you determine payment, and obviously, payment is extremely important. You need to pay your employees and you need to, or your subcontractors as well as employees, but you also need to stay on track with budget. And so this is a very good chapter. And this is something that construction management people use all the time. It might be one of the best chapters for construction management. So I'll be able to walk through most of the slideshow on this one and PowerPoint presentation. So I'm going to set that up right now, and we're now sharing. So here is chapter 19, quantity and final surveys. So quantity, we're talking about final surveys, things being done at the end of the project, and quantity is what you pay for. You pay for how much stuff you buy, or the quantity of things that you buy and put in, and that's what the contractor pays for. And then the owner who has delivered the product, he pays for, or she pays for, the quantity of things that are put in the ground or built. And so we're going to start to see that unfold here. Construction projects, their bids are usually lump sum or unit price. Either way, you're going to be wanting to track the quantity of material used to build something. Sometimes you're paid per linear foot or per ton or per cubic yard, and we're going to look at those things in a minute. Most of the time you want to put those things in a lump sum bid. You can try to make a little more money on the lump sum side. But if you ever have any extra costs, any redesigns and things, those tend to be on a unit price bid. So the types of units we're dealing with, so in feet or linear feet, or you would never want to, you would never use meters too often unless you're working with the government or the military maybe. So dealing with feet, all of these things here, curb and gutter, your sewer pipes, all of these things are, um, done by linear feet, and that's how they're sold, and that's how they're built. Excuse me. Area, we usually use, we don't really, sometimes we use acres when we're dealing with clearing and grubbing. Um, Sod, seeding, mulching, these are usually a smaller measurement like square feet. Road surfaces tend to be done in square feet also, or actually a lot of this is done in cubic feet, as we're going to get over here with volumes. They got it here as far as area, but when you're talking about mulching, I mean, how thick are you putting it? And when we get to road surfaces, we're going to be looking at uh, the thickness of the roadway and how that all comes into play. We'll look at that here in a few slides. So volume is cubic feet. It's a cubic measure, length times width times height. Volume tends to actually be done in cubic yards more than cubic feet. Uh, all of this stuff here would be laid out, and every bit of this would probably be done with cubic yards. Weight, literally, sometimes things are purchased by weight. Might be steel, maybe stone. Usually these are like per truckload, which comes approximately so many tons. Same with asphalt. All right, here's an example of sod being laid out. You might be asked to go and figure out how much sod was put in. So what you end up doing here is you create this baseline, this length of along, it looks like it's on a side road, and these are how much was laid out in, the grass on the shoulders of the road. And so you would start looking at this and trying to figure out, distances. You're pulling off the middle of the road. You have these different offsets that you're going, from the center of the road over, and you end up with an irregular shape. And you could put all this in a computer, and a computer program could figure out your area, and that's likely what you're going to do. Or you could start working out a series of triangles and rectangles and irregular shapes and start trying to put in how much sod you have by figuring out the area of a bunch of triangles and rectangles. Same type thing here in this particular slide. This is for a fencing that's being put in. You're looking more here at linear feet, not square feet, and you'll be able to just sort of go along. The thing here is you may not need to do it this way with linear feet. You could probably use a wheel and go along and see how much you put in with just one of those wheels that you walk along beside. This is something, literally for pile driving and how deep things went and then what piece they were cut off at and then how far is left in the ground. So, and this is, again, so it demonstrates the amount of work that has to be done. This is, they're called sheet piles. It's done to support like a dam. So it's, like I say, it's just another method of keeping track of something that's built. Now what everything is going to get into is some geometry, and here is some irregular uh, shapes. So you have to sort of figure out what this side of the shape is, and you can do that by averaging these sides here. So, if it's literally here, this one here, 35.2 and 34.8, this, you would just end up with a triangle here that's going to you go 34.8 this way. You'd add, so this is 15, the 34.8, you end up with a 0.4 over here, and you just make a triangle back to actually the other way, 35.2, so you're 0.4, and then back to here, and you're 15 feet, so you have a triangle that works like that. A little bit different example here. You would come down 40 feet, come over, subtract 40.5 from 45.1, and you're right here with a distance of 4.6 feet out to there, and then you have a triangle that's 4.6 by 15, so 1/2 base times height will give you this area, and it's good enough for what you're trying to pull off. I'm not going to go through all of these. There's a bunch of different formulas for various shapes that you could work with, but again, a lot of what you'll do would be utilizing a computer. Now, this is a good lesson right here. This is the results of a cross section. This is something I asked about in Module 7 about cross sections and their importance. So in this particular case, you have a cross section with a specific slope, thickness of the pavement that's been given to you, and here's your curb and gutter. Don't worry about this stuff here in millimeters. Basically, your job is to come in here and figure out how much asphalt and how much concrete curb needs to be put in place. So this is where you use this end area computation. So what you do is you take and figure out this much right here. And let's just say, here's another example. Well, not really. We'll stick with this one. And then you take this cross section of the road and you figure out how many feet you have to go and how long this cross section stays the same. Maybe the road turns in, it gets wider, and we have a turn lane at some spot. So this starts to taper out and we put in more pavement. Those are the things you look for in the cross sections. But in this particular case, you would take this area right here, and that's the pavement you put in, and you would multiply that by the length, the distance of the road, the center line of the road, for the amount of space or amount of cross sections it says you put in this particular one, And that would give you an area here with square feet, multiply it by the length of the road, and now you have cubic feet or cubic yards, and you have the volume of the asphalt that you put in, and the same with the curbing. The next slide is a little bit different. This next slide actually takes you a little step further. We have original ground and we have sidewalk. So we've got an extra component stuck in over here on each side. And we have this original ground. So what this is looking at, and really what you're going to get is you're going to get one more distance. This typically, you're going to have one more thing. And that would be down here, you have what's called subgrade. How much more are you going to take out of this road section and put gravel down? So the subgrade is always going to be compacted gravel when you're putting pavement on top of it. So you probably have another foot or something down here for your compacted gravel. And your job would be to first figure out the area from here down like this. You would come down and get the area of the gravel. You come over like this, and you keep measuring the whole area like that. And that gives you a square footage of this whole thing, and there's a way to get the area for it. There's a couple ways to do it. Doing this by a bunch of triangles in different shapes is a little tougher. A computer could certainly do it for you, and then there's another device called a planimeter. I don't know how many people would use a planimeter anymore, but I've used it many times where you're scaling an area on a set of plans, and the planimeter, you do a little bit of math to come up with this square footage. So the reason that you would look for an area on this particular cross section that includes all this gravel is so that you know how much dirt has to come out of here. This is the original ground. You have to take the original ground down to here and then fill back in with gravel and then asphalt and then curb and then slope it off and tie it in and then do a sidewalk. And again, you would figure out this whole area, and then you would go another 25 feet or something, and you do it again for the next section. And then to get your cubic feet, you would end up taking this area plus the other area, the next 25 feet down. You divide by 2 because you have 2 of them now, and you're in the middle, so you're averaging this. And then you multiply it by 25, and that would give you a cubic feet, which you could convert to cubic yards, and you would know how much ground, how much earth you have to actually take out in that 25 feet, as well as how much gravel would go back in and how much pavement would go back in. So that's the usefulness of a cross section. Here's just another picture of the same type of situation. Where you're actually doing these end area computations for a cut and fill section. And so you're just, computers figure this out for you. It's a good tool to know, and it's something you may have to work on. And if you just remember cross sections and end area computations, you could probably Google an answer if you forget, in 3 or 4 years, if you might have to do something like this. But this is an everyday process for engineers, surveyors, and construction people wanting to know the quantity of materials being used. Same thing here. This is what I was telling you about, a typical cross section and how much dirt is being removed. This is something that you'd have to deal with, again, regularly. Just another explanation for a fill section where you want to know how much dirt is being put in. From a design standpoint, engineers and surveyors try to balance a site in theory. We don't want to have to haul away much dirt. We don't want to have to bring much back in. We want to be able to handle everything on site. That's why roads end up on slopes like this, so that maybe what you're doing is you can cut some of this material out and fill it in over here. You try to put stuff on the side of a slope a little bit. Plus, it helps with drainage better. Looking here, this is exactly what I was telling you about, like a typical road section. You come up like this, one side is a cut and has a ditch, and the other side is fill. So this area here looks a lot like it could fill this one in completely, and that's what you want to try to achieve in a road design situation. Um, it's not always possible, but that's what you're after. Um, Same kind of thing here. You got a center line of a road, and you have all these. Just basically, this is a fill situation here. Down here, we're filling also, and so how much dirt are you going to put in here? You've got 800 to 900. You would figure out what this is, and they're showing it as going 100 feet. I would think that for the purposes of accuracy, you would be a lot tighter than that. I know I would do it a lot tighter, a lot smaller interval, but this is what I was telling you about an end area computation. You take this number here, you add them together and divide by 2, and then you multiply by the distance in between, which is 100 feet. So that pretty much takes care of the end area, or average end area measurements. Uh, Things like this, it's fine. I'm not going to worry about anything about a prismoidal formula, but what I want to talk to you now about is more the importance of the final survey in these quantity measurements and how things actually work. So the quantity measurements we've talked about, and we see how they play out. The things that we need to do as surveyors would come in, and surveyors do as-built surveys. They do final surveys where they measure things as best they can on the surface as well as what they can underground, so that you know the final location of things, including final location of elevations and locations of pavement, sidewalks, and those type of things. So you come in and you do this final survey, and it gets compared to the plan. Now, that's one aspect of a surveyor's part of it. The construction manager is going to be looking at all the quantities. They're going to compare the quantities that are done as part of the as-built survey and see if there's any differences between the proposed, and they're going to be looking at all the different quantities and why maybe something was off, and if it was off too much, was that because of a design change? Should you be getting paid for that or not? Those are the types of things that you're going to be involved in, and not necessarily the survey side. But almost every single project will have to have a final survey. Every single type of construction project will have a final survey. A lot of times it's to help release the bonds that municipalities and local governments place on construction projects. Bonding is not part of this course. It is part of my legal contracts course that's done in the fall. At least one of you had that last fall. And in bonding, what will happen is that a developer will propose to do a project, and it's all fine, but what happens if you go bankrupt? The town or the city doesn't want certain things left undone, so they make you put up a bond. And if you go bankrupt and you can't build it, the city will call the bond, and they will go ahead and issue a contract and have somebody build the rest of the project, or at least build it and stabilize it and that type of thing. So final surveys are very important because they show that something's been built correctly, and the government will release the bond back to the developer or the general contractor. So that's pretty much it for chapter 19. Don't get overwhelmed with a bunch of math. I'm not going to ask you anything about that. I might talk to you about some average end methods or things like that, but you're not going to be asked anything to do with having to figure out some irregular shape. So that's it for 19. I'll have one more lecture for you, a finals review, and I will see you shortly.